In this video, we will discuss how do we differentiate some function without using the definition of derivative. That's a painful method to use to differentiate, to find the derivative of some function, right? We don't want to use definition, so we like try to develop some new ways to find the derivative of some given function, right? So the first one here is an easy one. Let's try to start from constant function. So uh, let f of x equal to c, right? As a constant function. So you want to calculate f prime of x, right? This new function, right? So they are connected, and by our definition, to develop new rules, we need to apply our definition. For h goes to 0, f of x plus h minus f of x over h. That's our definition, right? So because in this case, the function is always a constant, right? So f of x plus h will be c, same as f of x. So this is equal to as h goes to 0, c minus c over h. So this is equal to 0. So we know that the derivative of a constant function is, let's use our notation, d over dx. The function is constant, always c, or you can write it as c prime. And so this is equal to 0. So whenever you try to differentiate constant, the derivative is always 0. So let's go to a little bit more complicated function. Let's go to power function, right? X to some number. Power functions. Power functions. Okay, so easy function. If you want to calculate the derivative of x, f of x is x, right? So this is equal to as h goes 0, f of x plus h, because f of x minus f of x over h, because f of x is h, is x, so f is x plus h, right? So this is as h goes 0, x plus h minus x over h. So this is h over h, which is 1, so this is 1 here. I can try to do more, right? In general, d over dx, x to n here, equal to n times x n minus 1. So this is true for general any power, right? No matter that's a integer or rational or irrational. So this is always true. So this is our power rule. D over dx, x to a here, equal to a times x to n minus 1, or a minus 1. So this is true in general, right? So let's see, let me rewrite it, make it clear here. That should be x a minus 1. So this is true for every number, right? Where a here is any real number, no matter you have 1, 0, or pi 1000. This is always true. Okay, so let's see a couple easy example. And the first one here, our function f of x is x to negative 4 over 3, right? So by our power rule, f prime of x is negative 4 over 3, x to negative 4 over 3 minus 1, right? So this is negative 4 over 3, x to negative 7 over 3. So negative 4 over 3 minus 1 is negative 7 over 3, right? And b, our function is f of x equal to e to 4 here. In this case, you can see that uh, although you have some kind of power representation, but that power, this function is always a constant, right? There's no x inside. No matter what is x, the function is always e to 4. So f, in this case, f prime of x equal to 0, right? One more example. See here is we have g of x equal to fifth root x cubed over x. Now, in this case, we have a fraction of power functions. And keep in mind, we don't have a way, a rule to differentiate both numerator and denominator, right? We only have power rule. So the first step is you need to write your function as a single power function. So this is x to 3 over 5 over x. So this is x to 3 over 5 minus 1. So this is x to negative 2 over 5. So g prime of x is negative 2 over 5, x to negative 2 over 5 minus 1. So this is negative 2 over 5, x to negative 7 over 5, right? So that's how do we differentiate this function here, right? So let's see more rules, right? So suppose you know how to differentiate some kind of function. How do we generate new functions, right? By our discussion before, we can multiply by a number, or we can take a sum, difference, or quotient, right? So what we want to do next is basically see how do we differentiate a new function by multiply by constant, right? So this is our constant multiple rule. And suppose you know one function is differentiable, right? So let f here be a differentiable function, and c be a constant, right? Now we get a new function. We want to know what is the derivative of c times f, right? And d over dx c times f of x. What's that? Right, let's try to find it, right? Use our definition. So we know that, or you can, a different way to say that, write it just c times f of x prime, right? So we can do that by our definition here. So this is by our definition, this is as h goes to 0. c times f of x plus h minus c times f of x over h, right? So this is equal to as h goes to 0, your common factor, which is c times f of x plus h minus f of x over h. Remember, when we introduce the limit laws, we can bring the constant out, right? So this is equal to c times as h goes 0, f of x plus h minus f of x over h. And we know that f is differentiable, so which means the second limit is basically f prime of x, right? So this constant multiple rule is this equal to c times f prime of x. You can differentiate that function first, then time the constant. Okay, then you can get new function by taking a sum difference. So let's see the sum and difference rule, right? And suppose we have two differentiable functions, which means the duality exists, right? Let f and g here be differentiable function I dot e f prime g prime exist, right? Now you want to know what is the derivative of a new function f plus g, right? How do we differentiate f of x plus g of x? What's the derivative of this function, right? How do we do that? So let's try to calculate that here, right? And then we write down the formula together as difference rule together because these two rules are very similar to each other. G of x prime equal to as h goes 0, f of x plus h plus g of x plus h minus f of x plus g of x. That's our definition of derivative. Now you can split it into a sum of two smaller terms. H goes 0, f of x plus h minus f of x over h plus g of x plus h minus g of x over h, right? You can see these two are same, right? You can split it, you can combine them. And now you know that f, g are differentiable, which means the first limit is f prime of x. Second limit is g prime of x. So this is basically f prime of x plus g prime of x. So that's our sum rule. So this equal to f prime of x plus g prime of x. So to differentiate a sum of two functions, you can differentiate each function first, then take a sum, right? Similarly, if you have f of x minus g of x, you want to find the derivative of this difference. This is f prime of x minus g prime of x, right? Just apply our definition uh, of uh, uh, of um, of derivatives. You can get the sum and difference rule, right? Okay, now let's see a quick example here. So we want to differentiate this function here, y equal to x cubed plus 4x to 1 over 4 minus 2 over 2 times fourth root of x. Right? You can see that's a big quotient. We don't have quotient rule yet. We don't have a rule to differentiate quotient. So we need to change our function to a format of sum or difference of power functions, right? Now what's this? So this is equal to, you can split it, right? This is 1/2 x cubed over fourth root of x plus 4 times x to 1 over 4 over 2 times fourth root of x minus 2 over 2 times fourth root of x. You can split it. The first one you can combine this as 1 over 2 x to 3 minus 1/4 because fourth root is x to 1 over 4, right? So you get 11 over 4. And plus the second number, just number, because the function will be cancelled. And the last one is x to negative 1 over 4. Now you can see that now we get a sum or difference of different functions. So we can apply the rules. Y prime is 1 over 2 times 11 over 4 x to 11 over 4 minus 1 plus 0. The derivative of constant is 0, right? Then minus negative 1 over 4 x to negative 1 over 4 minus 1. So this is 11 over 8 x to 7 over 4 plus 1 over 4 x to negative 5 over 4, right? So that's basically what is the derivative of this function. So here in this video, we have discussed uh, sum, difference, and constant multiple rule of how to find the derivative of some function.